right, Unit 8, Day 3, polar coordinates. So the whole idea here is for pretty much our whole lives, every math class we've had, we're in the coordinate plane. How do you get to point A? You go over 5. 1, 2, 3, 4, 5. Oh, jeez. Over 5 and up 3, and that creates a right triangle. So what are the rectangular coordinates? 5, 3. But now we're going to introduce another way of describing point A, or how to get to point A. Okay, so what do we have here? We have point A. We have a line coming out of the origin. We kind of make our little right triangle here. Over 5 and up 3. So now what we're going to do is we're going to find out what this angle is. And again, this is very similar to all the trig we've been doing. We're opening up the angle off the horizontal, going counterclockwise. We'll call that theta. Okay? So we're going to find that theta. The tangent of theta is going to equal opposite over adjacent 3 over 5. Again, that doesn't look like a 5, so let me try that again. All right, and what is that? The inverse tan. 30.96 degrees. So that angle there is 30.96 degrees. Nothing we haven't done before. Well, you know what? I also need to know what's the length of that. It's really a ray, but that segment there, the radius, well, we're just going to do Pythagorean theorem. The radius squared equals the sum of the legs squared. And then 25 plus 9 is 34, square root of 34. So what we're telling you now, the answer to this question here, if we use our trig knowledge, instead of calling that point 5,3, we can say open up at an angle of 30.96 degrees and extend a radius the square root of 34 units. And in a pretty basic way, that's how polar coordinates work, and that's what they are. It's just another way of describing points. And there's a lot of applications in math that we'll see eventually if we keep going. And I need to find out where my next page went. All right, here we are. All right, there's the right page. Okay, so I have some formulas here. Here's a little illustration. I'm going to get right into these A and B. Now, A and B are actually special cases. You don't actually need these formulas, and let me explain why. If we draw a little coordinate plane here, where's the point 0, 6? We all know that 0, 6 is right here. Well, if I need to convert this to polar coordinates, I have to find that angle. Now, you can try to do the formula. The tangent of theta is going to be 6 over 0. That's undefined. Your calculator won't help you. You're going to have to lean on your trig knowledge. But don't even think that hard. You know exactly what the angle that is. That's 90 degrees. And you know what else? You know exactly the length of that radius. You're just climbing up the y-axis. The radius is 6. And it's 90 degrees. Now, I do want to point something out. We do have in the formula, I told you we don't have to worry about those for now, and you don't, but I see a plus or minus. That means a radius could actually be negative, which is a little bit strange because we've never seen a negative radius before. But all you're going to do for a negative radius is the negative radius is going to be 180 degrees away from the true angle. What do I mean by true angle? What's the angle coming off the horizontal going counterclockwise? What's the angle that's going to give us the point 0.06? That's positive 90. So if you look at 180 degrees added on top of that 270, this is how the negative radii work. Go 270 degrees and then shoot through the origin. If it's negative 6, shoot through the origin 6 units. It's going to take you right back to that 0.6. So these two polar coordinates, those pairs of polar coordinates, they describe the exact same point. Okay, similar concept over here. Now I'm giving you the polar coordinates, and let's graph that. Negative 270 takes me clockwise 270, and I go up 10 units. So that's going to be 0 for an x coordinate, 10 for a y. So those are special cases. They're actually the easier ones. more often than not, you'll have to do a problem like example C. Convert using both negative and positive radius. We're not going to mess with the negative and positive radius. I just want this in your notes. So negative 3, 7. I'm going to need to find the radius. So the radius is going to equal plus or minus the square root of negative 3 squared plus 7 squared. That's 49 plus 9. That's going to be 58. So my radii are going to be plus or minus 58. I'll use the plus first. And then the tangent of the angle is going to be 7 over, the inverse tangent of 7 over negative 3. And here's a little minor issue, not too bad. We get a negative angle. Now we know that a negative angle goes clockwise. Negative 66, that's going to be somewhere over here in the fourth quadrant. But where is negative 3, 7? Negative 3, 7, that's a quad 2 angle. So use your knowledge of reference angles, wipe off that negative, write down ref angle if you have to, 66.8, and apply that to the second quadrant. Subtract that from 180, 180 minus 66.80. And you'll get 113.20. That's a second quadrant angle. So we're going to have square root of 58, 113.20. That is one of our answers. That's our answer with a positive radius. Now here's the great thing about the negative radius. You just have to add or subtract 180 degrees to the angle. Well, that negative 66.8, that's fine. Nothing wrong with using a negative angle here. We don't have any restrictions, so that's fine. If you wanted to add 180 to this and get 293, that is also a fourth quadrant angle that's positive. All of these points, 20. All of these points, 1, 2, 3, they all describe the exact same point. All right, moving on. All right, so plot point B at 230 degrees. That's somewhere around here. Okay, now what are the rectangular coordinates there? Let's try to figure this out on the fly. If I draw my radius, it would help to know what the length of the radius is, so let me count the blocks. 1, 2, 3, 4, 5, 6. That's a radius of length 6. If I draw myself a triangle here, how many degrees did I go all the way around? 230. Subtract off those first 180, and what you have is, you have a right triangle with an angle of 50 degrees and a hypotenuse of 6. All right, so now all we have to do is, if I want to find out what that x-coordinate is, I can say the cosine of 50 equals adjacent over hypotenuse, x over 6. So then when I multiply by 6, I'm going to get 6 cosine of 50, which will equal 6 cos 50, 3.86. Then I can say the sine of 50 is y over 6, opposite over hypotenuse. So 6 sine 50 will equal y, which will equal 4.60. So now, what are the rectangular coordinates? X coordinate, comma, y coordinate, and there you go. So we kind of just figured out how to convert them on the fly using our old trig knowledge. Now look at what I did. Radius cosine 50, that equals x. Radius sine 50, that equals y. Look back to the previous page when I gave you the formulas. That's exactly what the formulas are. Going polar to rectangular is pretty simple. You just take the radius cosine angle, radius sine angle. Cosine has always been affiliated with x since day one. Sine has always been affiliated with y, so that doesn't change. So let's go and take a look here. Convert -5, -12 to polar coordinates. Okay, we did one of these on the previous page. The radius is going to equal plus or minus the square root of -5 squared plus -12 squared. You may recognize 5 and 12 from the Pythagorean triple, 5, 12, 13. If not, just do the Pythagorean theorem and you'll get the square root of 169. Radius is plus or minus 13. Now I'm going to find the angle. The tangent of the angle is going to be -12 over -5. Inverse tan of -12 divided by -5, you're going to get 67.38. So theta equals 67.38 degrees. Well, here's the thing. That's a first quadrant angle. -5, -12, that's a third quadrant angle. That's the wrong quadrant. So the quick fix is, okay, so then just go, if it's the wrong quadrant, go to the negative radius. Done. But if you don't like the negative radii, okay, not a big deal. Add 180. Do we always add 180? Well, for tangent, if you're in the first quadrant and you want the other positive, then yes, because your tangent is positive in the third quadrant. So the other theta you could use is 247.38, and that's if you really wanted to use a positive radius. But negative radii are valid. So either one of these two answers would be acceptable. And last, we'll do example E. This one is probably the easiest one. X equals -8 cosine 60. Well, cosine of 60, I know what that is. That's -1/2, or that's +1/2. -8 times 1/2. Or just use your calculator, -8 cosine 60. It'll back you up. The answer is -4. Y equals -8 sine 60. I happen to know that the sine of 60 is the square root of 3 over 2. You know that also. -8 times the square root of 3 over 2 reduces to -4 square roots of 3. If you give me the decimal version, I'll live. And the, oops, this should say rectangular. Those are polar. So the rectangular coordinates are -4, -4 square root of 3. Done. If you saw that originally and you just said, nope, I'm going to answer it as you told me, the polar coordinates are -8, 60 degrees, you win. All right, that's all I have for you.